guys, welcome to the Spring 2024 final review for On-Level Algebra 2. So this video is for you guys to take notes and use these notes on your final. So all of the problems that you see today are going to be very much like the problems that you see on your final. So keep in mind that when I grade your finals, if you do not show work, I am not going to give you credit for that problem at all. So please make sure that you have these notes so you remember how to work out these problems. So your final is going to have 18 multiple choice questions that you are required to show your work on, and there will also be 4 free response questions that you are required to answer. They are not bonus questions. Starting out with the first topic that we covered in this semester is exponentials and logarithms, and these are the different lessons that we are covering in this topic. Starting out with attributes of exponentials. So what we're actually going to do here is go to Desmos for these ones, but go ahead and take a moment and write these equations down. So here we have that first graph, 3 times 2 to the x plus 1. And here we have the graph shown. So there are 2 things that you should be able to identify very easily from the graph. So the first thing that you should be able to identify is the asymptote, which in this problem, the asymptote is going to be horizontal. So remember that an asymptote is, in the words of some of y'all, the line that the graph looks like it's on top of. So in this case, the asymptote would be this horizontal line because our graph, our red line, looks like it's starting to go on top of that horizontal line. So here, our asymptote is going to be y equals 1, because the number that this horizontal line is going through is 1, and that is a y value. The other thing that we're going to be looking for on this graph is the x-intercept. Now, sometimes it may happen that your graph does not have an x-intercept. And in this one, this is the case, because as I go forever, it's looking like it's going to be flat forever. It's going at y equals 1 forever, so it is never going to cross the x-axis. And so it's okay if for x-intercept my answer is none. So for 3 times 2 to the x plus 1, my asymptote's y equals 1. My x-intercept is none. For the next graph, 2/5 to the x minus 2 minus 3. Obviously, very different looking graph. Now it's going down, and I see that it's moved down. It's not at y equals 1 anymore. My asymptote is instead over here, okay, because that's the line that it looks like my blue graph is on top of. And if I look at the number that this horizontal line goes through, it is -3. Specifically, y equals -3. And you do have to get specific with that y equals. Okay, and if you are showing your work on your paper, please draw a picture of the graph that you are seeing. Okay, and especially if it's asking about the asymptote, please be specific. Please be precise in what you're drawing so that it shows me that you know what it is talking about. Okay, and in this graph, there is going to be an x-intercept. Now remember, the x-intercept is where it crosses the x-axis, the horizontal line. So here, if you just click on it, if you know the right spot to click, it will tell you what it is. So here, the x-intercept is 0.801, 0. And that's your answer. Going back to our slideshow, we have writing an exponential equation from a word problem. So you are going to be given a word problem, and it is going to give you this information, something very similar to this. Okay, and from the word problem, you're going to need to determine all of the stuff that it's asking for right now. So it's talking about a bank account with an initial deposit of $250 and an annual interest rate of 3.25%. And then find the balance of the bank account in the year 2020. Well, your starting value, and so I would definitely write this in your notes for a word problem. Starting value, you need that. Here, our starting value is our initial deposit of $250. So I'm going to put 250 right here. It is saying that it has an annual interest rate of 3.25%. In a bank account, if the bank account is paying you interest, that means that the money in the bank account is going up. So here, that's going to be growth. My rate of growth is going to be 3.25%. But I have to change that to a decimal, not a percentage. And I do that by taking that decimal and moving it to the left twice. So my decimal version of this number is 0.0325. And since it is growth, I'm going to do 1 plus. So let me write this equation. Okay, I'm going to have that y equals my starting value. And since it is growth, and you are going to have a growth problem, so you don't have to worry about decay, it's going to be 1 plus that decimal to whatever that time is. Okay. Now, in this specific problem, it is asking you to find the balance of the bank account in the year 2020. I'm not going to plug 2020 in for X. I'm going to plug in 12 because it's been 12 years since 2008 when it is 2020. So to find my answer, I'm going to plug 12 into this equation for X. And then I will plug it into a calculator. And when you plug that into a calculator, it gives you something like $366.96. Ta-da. And so that's how you would do one of these problems. Again, starting value, change the percent that they give you to a decimal, and then plug it into this formula. Okay, starting value first, then 1 plus that decimal that you made. Okay, and then whatever it's asking you about, you're going to plug that X value into X and plug that into a calculator and get your answer. Okay, so the next type of problem we're going to talk about is logarithms and exponentials as inverses. And there are going to be two types of problems about this topic. This specific type of problem we're looking at right now is going to be one of your free response questions. So you do need to write this formula down. So we have log with a base of b of a equals x, and then that can be rewritten as b to the x equals a. So if I look at the first row, I have a base of 2 here. So, base of 2. Where x is, in this equation, I've got a 3. So my exponent's going to be 3. And then it's going to equal 8. I would write all these examples down so you know what the heck is going on, so that you can recognize the pattern. Okay, on to the next one here. The base is 4, so I have a log with a base of 4. Where a is, I have a 16, so that'll be 16, and then equals whatever the exponent is, which in this case it is 2. Okay, again, going from log to exponential, I have a base of 2, so I have 2. I have that where the x is, it's a -2, so I have an exponent of -2. That's okay, that happens sometimes. And then where a is, I have a 1/4, so it's going to equal 1/4. And finally, going from exponential to logarithmic, I have a base of 7, so I'm going to have log base 7. Where a is, I have 343, so I'm going to have a 343 here. And that is going to equal 3. That's the only number that's left. Okay, so you do have to know how to do this problem. Please write this down, please. Let me pause it, please. The other type of inverses problem that we're going to see should seem familiar to some of us at this point because we just did this with cube roots and cubics. But we're talking specifically about exponentials and logarithms as inverses. So I would write down somewhere that logarithms and exponentials are inverses of each other, that they are opposites of each other. Okay? And like we talked about with cubics and cube roots, I am fine if for rationale on your paper you put that you were looking for opposites. Okay? So I'm just going to do shortcuts right now because this is our final. I'm not going to get super into it, okay, for the sake of time. So in our original function that we are given right now, okay, in the original, we are given, it's an exponential with a base of 3. That's one thing we got going for us. The other thing is that we have plus 7 inside with the x. Okay? Now, in my inverse, I'm gonna have the opposite thing. I'm gonna have a logarithmic. So I'm gonna see the word log. And then, instead of a plus 7 inside, I'm gonna have a minus 7 on the outside. Okay? So what is that gonna look like? I'm gonna have that my inverse is a log with a base of 3, because that's the opposite. I'm gonna have the x, and then I'm gonna have minus 7 on the outside. This is my inverse. Remember, I just want you looking for opposites. This is not a crazy difficult problem, and I don't want you to waste brain energy on something like this. I want you to go for the shortcuts right now. Okay, so looking at the next example, because you're going to see one of each of these. I'm looking at my original, the one that they gave us, okay? It is a log with a base of 5. This can be exactly how you show your work. And I will accept it like this. Okay? If I'm multiplying by 1/3, like that, that is the same as dividing by 3. Okay? And so this is important that I'm saying this because what I'm going to look for in my opposite is multiplying. Why can't I spell? Dividing by 3 outside is what that's supposed to say. So in my inverse, I'm looking for an exponential with base 5 and multiplying by 3 inside. So what's the inverse going to look like? I'm going to have an exponential with a base of 5. And I'm going to be multiplying by 3 inside with the x. And that's the inverse. Okay? So the opposite of 1/3 is going to be a 3 on the inside, multiplying on the inside. Okay? Keep that in mind, please. If I saw a 3, the opposite of that will be looking for a 1/3 somewhere. Please keep that in mind. Okay, so next for attributes of logarithms, we're going to talk about the logarithms. And we're also going to go back to Desmos for this one. So I'm going to hop over to Desmos. Okay, starting out with 2.5 times log base 10 of x minus 4. That's our red graph that we see here right now. And one thing that I want to note, and I'll mention it again, is that if you see something without a base, it is the same thing as log base 10. Because look, I don't have a base 10, and then I have a base 10. It is the same thing. Okay, now talking about what I actually want to talk about, we are again going to look at the asymptote and the x-intercept. Important. Okay, so here, easy. First, I'm going to look for the x-intercept. Ta-da! It is where it crosses the x-axis, and here my x-intercept is 5, 0. Please know how to look for the x-intercept. Okay, next I'm going to be looking for the asymptote. Again, remember, that is the line that it looks like my graph is on top of. And if I follow this, yep, it looks like it's on top of whatever this is. So if I draw a line here, okay, and again, when you're showing your work, if you do a little sketch like this, and you're like, it looked like it was on whatever it is here, this number that it looks like it's going through, this line, is 4. Specifically, x equals 4. Okay, that is my asymptote. So remember, an asymptote is that line that the graph looks like it's on top of. Write that down somewhere, please. Okay, there will be a question that asks you specifically about what even is an asymptote. And so you need to be able to recognize what an asymptote is. All right, going to the next graph. Again, x-intercept, looking for it on the graph. Here it's at negative 5. So my x-intercept is at negative 5 comma 0. And now asymptote. Okay, that line that it looks like my graph is on top of. I'm following this green line. Okay, and it looks like my graph just goes to a straight line right here. That is going to be where your asymptote is. Okay, so here, number it looks like it's going through, well, this is negative 5, negative 6, negative 7. And specifically, this is x equals negative 7. And yes, you do have to be that specific. Whatever note you have to make to yourself, please make it. So that you know how to be specific with x equals or y equals. You've gotta be specific. Alright, next, solving logarithmic equations. And I just want to say at this point, if I have shown you in this video to work out a problem a specific way, and for example, a problem like this, you just take the equation, you plug it into Desmos, and you give me what x value the line goes through, that does not count as answer. Desmos is not valid work for these types of problems. If I see this, let me just tell you right now, if I see this, that does not count. I don't want to see that. Please do not do that because you are not going to get credit for it. A problem like this, they all have the same number on the bottom, right? This is super nice. This is a super cute problem. So what happens is, on this side, I can take these two and I can combine them into one log. Now, how am I going to do that? Since there is an addition sign between these two logs, I will multiply what was inside of those two separate logs. Okay. Whoop. Now what do they have that's the same on both sides? A log base 2. If they're both the same, I can get rid of them. So now I've got 4x times 5 equals 80. 4x times 5 is 20x. And I want to get x alone. So divide by 20 on both sides. And you get that x equals 4. And you can always use a calculator for that last part. You can always use a calculator. Let's look at the next one. Okay, again, they all have the same little number on the bottom. So I know that it's this type of problem. I am going to combine the two logs on this side of the equal sign. They're both going to be log base 5. How am I going to combine them? Well, it is not addition this time, but it is subtraction. So instead of multiplying, I am going to divide. Now, I will tell you right now that this is more like the one that you're going to see on your exam. So please be warned. Right, so again, same logs on both sides, beautiful. I can just take them away. And I've got 7x over 3 equals 21. And I'm solving for x. So first, I want to get rid of that fraction. I multiply by 3 on both sides. I've got 7x equals 63. Finally, divide by 7 on both sides to get x alone. And I get that x equals 9. So please, 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 please write down how to work out one of these problems so that you know how to do it. Okay, moving on to polynomials. So I know it looks like a lot, but we have talked about this before, and I will show you the specific types of problems that you will see on your test that have to do with these topics. Okay, so here it asks to find the perimeter of the following rectangle. Okay, now perimeter is when we add all of the sides together. Okay, so make a note of that to yourself. Pretty please add all the sides together. Well, if this side is 3x plus 5, that means that this side is also 3x plus 5. If this side is 3x squared plus 6x minus 10, that means that this side is also 3x squared plus 6x minus 10. And to find the perimeter, I'm just going to add all of these things together. And if you remember how we did this when we first learned how to add polynomials together, is we stacked. Okay, and we put the like terms over each other. So I'm going to start out with 3x squared plus 6x minus 10. And on top of it, or below it, I'm going to stack 3x squared plus 6x minus 10, that other side. Then another side, 3x plus 5. And then another side, 3x plus 5. And what am I going to do to combine these? Combine like terms down the columns. So if you want to use a calculator for this part, you can. Negative 10 minus 10 plus 5 plus 5. That's going to leave me with negative 10. If I want to add all these together, 6x plus 6x is 12x, plus 3x is 15x, plus 3x is 18x. And then these two terms, 3x squared plus 3x squared is 6x squared. And that's it. That is the perimeter of the following rectangle. And it's okay that it's not a number, because guess what? They didn't give us numbers. So there's no way we could have found a number here. Moving on to area. So area is when we, it's when we multiply the sides together. Okay, so here they gave us x plus 7 times 3x minus 8 is our area. Okay, one side times the other side, my length times my width. How do I multiply this stuff? The area model. Okay, well, there's two ways to do it. So first, I'm going to do the area model, or the box method. Some people don't like the box method, so I'll do it another way too. And you pick whichever way works best for your brain. So I'm going to draw the box. Ta-da! And on one side, I'm going to have the x plus 7. On the other side, I'm going to have 3x minus 8. And what's going to go inside is when I multiply each side together. So 3x times x gives me 3x squared. 3x times 7 gives me 21x. Negative 8 times x gives me negative 8x. And negative 8 times 7 gives me negative 56. So I take this out here. And I really just need to combine those middle two like terms. And that gives us 13? 13x. And ta-da! That's it. That would give you your area. And so I will also do this another way. The other way that people like to do this, the other method, is called repeated distribution. And so some people call this foiling. And I think that calling it repeated distribution helps me remember what it's all about more than FOIL does, but that's just me. So x plus 7 and then 3x minus 8. So I'm going to look over here and I'm going to distribute this x to the 3x, but also to the negative 8. And I'm going to take this 7 and distribute it to the 3x and also to the negative 8. So x times 3x gives me 3x squared. X times negative 8 gives me negative 8x. 7 times 3x gives me 21x. And 7 times negative 8 gives me negative 56. And of course, I should end up with the same thing. I combine those middle like terms, get 13x, and ta-da! That's it. Okay, and on to a lot of people's least favorite topic, which is dividing polynomials. You are going to have a problem over dividing polynomials, and again, show your work, okay? There is no way that Distance is going to help you with this one. So we always start out with this first term, okay? We are going to kind of draw a box, except it's not going to be a box yet. It's kind of going to be like an E. And we kind of form our box as we figure out how many terms go inside it. So the first term goes on the inside. This short polynomial is going to go on the outside, on this side. Okay, and inside this first space, I have my first term. Now, what's going to go on top of the box is what multiplies with 3x to give me 9x to the third. Well, to get to 9, I have to multiply 3 with 3. And to get to x to the third, I have to multiply x with x squared. So the exponents add up to whatever I end up with in there. All right, so continuing, I finish out this space. So since I have these two terms here, I can multiply them together. 2 times 3x squared is 6x squared. Now, if I look over here, do I have 6x squared? No. I have 27x squared. So what I have to put in this diagonal is something that will add with 6x squared to get 27x squared. So I have to put 21x squared. Because now when I combine these two pink terms that are in the diagonal, it's going to give me the 27x squared that I want. Okay, and now I see what will go up here. What multiplies with 3x to give me 21x squared? 3 times 7 gives me 21, and x times x gives me x squared. Now I see what's going to go down here. 2 times 7x is 14x. Now if I look up here, I do not have a 14x. I have a 17x. So what I have to put up here is what is going to add to 14x to give me 17x. And that'll give me 3x. So what multiplies with 3x to give me 3x? It's the same thing, so that means that it multiplies with 1. And then I can finish out 2 times 1 is 2. And I have a 2. So we're done. And our answer is 3x squared plus 7x plus 1. All right. Moving on to the next one, which is going to be very similar. Let me scoot this over. I have very similar process. I draw out my box that's not quite a box. I put the 3x plus 1 on this side. And on the inside, I start out with my first term. So I start out with what is going to multiply with 3x to give me 6x to the third. 3 times 2 gives me 6. And x times x squared gives me x to the third. Next, I can fill out this box. 1 times 2x squared is, shoot, I wanted it to be pink, 2x squared. Do I have a 2x squared? No. I have a 5x squared. So what do I have to add to 2x squared to get to 5x squared? 3x squared. And so what do I have to multiply with 3x to give me 3x squared? Well, just multiply with 1 to get to 3, and multiply by x to give us x squared. Then I have 1 times x, which is just x. And I do not have a 1x. No, I have a negative 20x. So what do I have to combine with x to give me negative 20x? Well, to go from 1 to negative 20, think if you had $1 in your bank account, you ended up with negative $20. How much did you spend? Negative 21. Okay, you spent $21. You went down by $21. Okay. And so, what multiplies with 3 to give me negative 21? Negative 7. And so then I continue. 1 times negative 7 is negative 7. And I do not have a negative 7. I have a negative 5. And to get from negative 7 to negative 5, I have to add 2. And so, here we end. My answer is 2x squared plus x minus 7 with a remainder of 2. And that's the end of that. All right, factoring by grouping. Now this is one of your free response questions, factoring by grouping. If I see 4 terms like this, it's a factoring by grouping problem. So I start out by drawing the box. And I just put these terms inside of the box. X to the third, 7x, negative 7x squared, 4x, and negative 28. Now what I'm looking for is what term does each row have in common right now? Well, if I'm looking at my first row, x to the third and negative 7x squared, I can take out an x squared from both of them. Okay. In the second row, what they both have in common is that 4x and negative 28 can be divided by 4. Then I look at the columns, okay? X to the third and 4x have an x in common, just one, just x to the 1. And then negative 7x squared and negative 28 are both divisible by negative 7. And so these terms on the outside, they are the answer. I've got x minus 7 times x squared plus 4. And that's it. It has been factored by grouping. All right, up next we have factoring by difference of cubes. Now this is a formula. You have to write this formula down. Okay, you have to write this formula down and the example so you know what to do with it. Okay, so what are we going to do with this? All right, so starting with 64x to the third. That's going to be my a cubed term. Well, I have to break 64 down to what multiplies by itself 3 times to give me 64. Well, I'll tell you right now, 64 is 4 to the third power. Okay? So 4 to the third power, x to the third power gives me a to the third power. Then what's just plain old a? 4x. The things without the third power. Right? Next, we've got I don't have to include the negative. So my b cubed term is simply 8. Now 8 is 2 to the third power. So then what's b? It's just 2. And so, factoring by difference of cubes, I take the a and the b and I plug it into this part of the formula. So, when I plug it into difference of cubes formula, it gives me 4x minus 2 times, this was a mistake, 4x squared plus 4x times 2 plus 2 squared. Hey, that's a lot of the points right there. If you're able to figure out what a and b is and just plug it straight up into that formula like that, I love it. Love to see it, because this is a free response question. So 4x minus 2. I square 4x squared, and it gives me 16x squared. 4x times 2 is 8x. And then 2 squared is 4. And so this is my final answer. Ta-da! And that's that on that. All right, the final topic from Unit 8. This is going to wrap up the third 9 weeks part of this review. Everything else will be from this report card from pretty recently, after spring break. But this is the last of pre-spring break material. So let's take a look at this graph. This is also going to be free response. Okay? Now, I want you to remember that a 0 is an x-intercept. Okay? We are looking for x-intercepts. Now, the two x-intercepts that we see here are at x equals -4. So, hey, that's one. And the other one is at x equals 5. Now, the one thing that I want you to remember, well, I want you to remember many things here, or you could write the example down, whichever way. When we have the 0, we are going to change it into a factor, meaning we're going to change it to a set of parentheses with an x plus or minus some number. Now, if x equals -4, then remember that when it goes inside the parentheses, I'm going to switch that sign to x plus 4. So that means that for my 0x equals 5, positive 5, when I rewrite it as a factor, I'm going to rewrite it as x minus 5. Hey. Now, multiplicity. I want you to remember or write down that if it's just straight up crossing, like it's just going through the x-axis like that, like whoosh, like that, that is a multiplicity of 1, okay, because it crosses the x-axis. For x equals 5, notice that it's not going through the x-axis. No, it is simply touching the x-axis. Now, if it is touching the x-axis, if it's bouncing off of it, if it's a bump on the x-axis, that multiplicity is 2. Because it touches the x-axis. Okay, and so when I write my equation, this is what's going to happen. Y equals, as always. Then I've got my first 0, x plus 4. And since it's a multiplicity of 1, I don't have to put a power. If you wanted to, you would put a power of 1. But remember, if we put a power of 1, we don't usually have to show it. Then for my next 0, I've got x minus 5. And since it's a multiplicity of 2, on that factor, I put a power of 2. And then that's it. And we're done. Yay! For the sake of making all of our lives easier, I'm going to cut this video short here, and I'm going to continue with the next video, or the next stuff from this 9 weeks, in a separate video. So you guys can start working on this one, and then work on the next one afterwards. Okay, so I will see you in the next video.